Smokey the Bandits in one day too.
I watched all the Rambos in one day.
That's two. That's another one.
All right, let's get started. We've got a lot of great stuff to cover today. Is there an extra? Oh, here it is.
The last one?
Homework due tomorrow, 1:30, which means that if you've got questions on that assignment, you can ask me your questions during my office hours after class tomorrow, or of course you can email me, like that option's always available. We won't have class on Memorial Day, and the project is due on Thursday. All right? I really want to stress the importance of going through those manual calculations, because once you've gone through it manually, you're going to see how everything interrelates, and then setting up the spreadsheet will be a snap. So it's not going to take you extra time to do those calculations by hand. It's going to save you time. We're going to talk about some new methods on comparing alternatives today, and we've got a brief in-class exercise that goes along with that, so we'll just go ahead and get started. Remember, yesterday we were comparing alternatives by doing equivalent worth methods, and so we would have two different alternatives. Maybe they last a different amount of time. So we learned a couple of techniques to account for the fact that some equipment lasts for shorter periods than others, and so there was the repeatability method. There was the method where you can lease equipment for the remainder of the shorter lifespan to go the entire study period. You can sell the equipment that lasts longer at the end of the lifespan of the shorter equipment. Or you can invest the revenues from the shorter equipment in some external rate of return for the remainder of the lifespan of the longer equipment. Those were some of the options that we outlined on the board, and hopefully you wrote down that list of possibilities. So one interesting thing to look at is that internal rate of return is not a good way to compare alternatives. So what we said is that you can use any one of the equivalent worth methods. You can either use future worth, present worth, annual worth, and any one of those is going to identify the best alternative. And so comparing option A and option B. Option A costs $60,000 and generates $22,000 for 4 years. Option B costs $73,000 and then generates $26,225 for 4 years. And so if you do the present worth analysis, you see that there's more present worth for option B when these cash flows are discounted at 10%. But if you do the internal rate of return, what you'll notice is that the higher internal rate of return is associated with project A. So why do you suppose there's that discrepancy? Why is it that the equivalent worth method would tell us to choose B, but if we didn't know better, and we thought, oh, we'll just go by what has the highest internal rate of return. If we didn't know better, then option A would look best. Why the discrepancy? You don't have to get it right, you can guess. You guess wrong, you still get to stay in the class. You're not kicked out, you pay tuition.
Does that have to do with the MAR?
What's that?
Does that have something to do with the MAR?
The MAR, okay, it does. When we did the present worth analysis, we were discounting everything at the MAR. When you do an internal rate of return, what you're doing is you're discounting everything at the internal rate of return. That tells part of the story. That's part of the difference, is that we can go get money for 10%. And so we want to get as much profit as possible. Which of the two alternatives is more expensive? Up front. B costs more to go out and buy. Is it worth spending extra? You can get the job done for $60,000. Is it worth paying extra for option B? What's the advantage of option B? Even though it costs more, what's the advantage? It generates more revenue. So is it worth the extra? Because for me to go buy option A, I've got to borrow from the bank $60,000, and I'm paying the bank 10% to borrow that money. So I can either borrow $60,000 or I could go borrow $73,000. So why would I borrow $73,000 if buying the $60,000 piece of equipment would work just fine?
$73,000 over the 4 years, the difference between the 73,000 and the 60,000 is less than the.
So you're saying
It's
something.
less than the difference in the revenue
Okay, so you're saying the extra cost
spread over.
for option B, and you're saying spread over
The
the 4 years that it's going to last.
Yeah.
What's the result of the extra cost for option B?
It's less than the. It equals out to being less than the.
Is less
than the difference between the 60,000 spread out with the less revenue of A.
is less than the extra revenue. So it's costing me an extra $13,000, but the extra revenue I can produce is worth it. Because even though it has a lower internal rate of return, think of it this way. I borrowed an extra $13,000, but it only cost me 10% to borrow it. And that extra money that I borrowed, it generated 16.3%. What if you could go to Huntington Bank and they'd let you borrow $100,000 at 10%. And then you walked around and you went to Fifth Third Bank around the corner and you deposited in a savings account that paid 16.3%. And that'd be a pretty sweet deal, right? All right, so it's the same exact thing here. You can borrow $60,000 and go deposit that $60,000 at SunTrust Bank, and that pays 17.3% at SunTrust. Or you can borrow $73,000 at the same interest rate and go deposit it at Fifth Third, and they'll pay you 16.3%. But SunTrust, they won't take that much. SunTrust is only going to accept a $60,000 deposit. So what should you do? Should you borrow the $60,000 and pay 10% interest and go invest it somewhere that the return is 17.3? Whoa, this is the higher return. Yes, but this other bank will accept a bigger deposit. Even though it's a lower rate of return, in the end you're going to make more money because it's a larger amount that you're able to invest. Does that make sense to everyone? Aaron's not shaking his head. He's more of the strong silent type. Good. I'm more of the weak, loud type. So I respect the strong silent type as well. So this, what we basically did is we said, well, let's compare A versus B. And what Andrew said is the extra cost for option B is less than the extra revenue. So there's lots of different ways we can think of it. We could say there's some extra revenue each year, and we could take those extra revenues each year, take them to the present. Or the way he was thinking of it is he'll take the extra cost in year 0 and spread it out over A. And then find out what's the extra cost versus the extra revenue. And then, therefore, make the determination if the investment is justified. So, just to emphasize this point, the internal rate of return sometimes doesn't identify the best project. Often it does. You've actually got to be a little clever to arrange an example that gives you one answer that's one way and the other. I mean, internal rate of return usually would indicate the best, but not always, and so we don't want to use a flawed method. Present worth analysis would always give you the best alternative. Okay, so here's essentially the way we set it up. We find the extra cost between B and A, and so you know yesterday how I said I wanted to arrange my columns in terms of increasing upfront cost? The reason why I do that is for an incremental analysis like this. I'm going to have B minus A. And so the more expensive option minus the cheaper option in this third column here. So the extra 13,000 is 73 minus 60. And then I have the extra revenues. And so this is showing me the extra cost and the extra revenues. I can discount those extra revenues at the 10% mark and calculate the present worth. And so this is just saying, I know I'm already going to get interest on everything else too, but what's the interest on the extra amount? The interest on the marginal cost. So that added amount would return me 11.4% rate of return. And so that's higher than 10, so we still would go with, that's a confirmation that option B is a good choice. We already knew option B was better just by this method. This already told us the present worth of B is better, but this gives me more specific information. It tells me of that extra $13,000, how much extra profit I'm making over and above the 10% that I have to pay to borrow the money. Or, stated another way, what's the internal rate of return of the extra amount? This 11.4%, that's not the internal rate of return of the whole project B. That's just the rate of return of the extra amount that I borrowed. Any questions about that? So here's our rule. If the internal rate of return of the difference is greater than the MAR, then the additional investment is justified. If you can invest money cheaper than you can borrow it, borrow as much as you can. And that's what the banks do, right? The banks, they borrow money from the government at very low rates of interest, and then they loan it to people for houses, they loan it to businesses for equipment, they buy subprime mortgages that are poorly collateralized. They shouldn't do that last part, but so why the discrepancy? Just again, this slide is a summary of why sometimes the internal rate of return isn't the whole story and can't give you the answer on what to do. It's when you take the internal rate of return of the marginal cost, the extra amount, that you get the real answer. Yeah.
Who's over the U.S. Treasury? I just don't remember. Is it Bernanke?
Geithner?
I don't know.
Geithner. Bernanke is the head of the central bank. And the central bank is independent of the government. The Treasury is a post appointed by the president, but Bernanke is confirmed by the Senate. But they're in cahoots. They're in cahoots. The central bank will buy the bonds issued by the Treasury to keep the rates low. So that if there's ever an auction where people don't want to buy U.S. debt, they'll buy the U.S. debt.
So what's the point in having them separate?
I don't understand that part, actually. I don't know. I mean, there is a point. I just don't know what it is. I think it's so that monetary policy isn't influenced by politics. You know, like if a politician who's going into an election year wanted all of a sudden there to be everybody to have their pockets full of money, I mean, there'd be long-term negative consequences, but if a politician like the president could exert political pressure on the central bank to say, lower the interest rates super low, so it has this quick burst of stimulation of the economy, even though it may cause inflation or something. So I think it's to avoid pressures like that. All right, we've already talked about the difference between the two and the way to think of it. And here's a graphical illustration. Okay, so what this shows is that Project A, the present worth of Project A when we discounted it at 10% was $9,738. 10% is how much we had to borrow the money for. And so option A wasn't as good as option B. But when we're discounting things at increasing interest rates, then there's this crossover point at which the internal rates of return are the same and you'd have the same present worth. So if it costs you more money to borrow your cash than 10%, then another of the options may be better. So this shows that that option B, which was better at first, it stops being better at 11.4%. If you have to pay 11.4% or more, then it would have been better to have option A instead of option B. So this is a graphical illustration of, on this axis, the interest rate that everything is discounted at, and on this axis, the present worth of the cash flow diagram. And so what this curve shows is that as interest rate increases, then it changes which of the two projects is more profitable. There isn't always a crossover point like this. It's just in this particular example there was a crossover point. I already mentioned that it can sometimes be a little tricky to arrange a cash flow diagram that can have the discrepancy that this illustrated. But the simple fact that it's possible, internal rate of return could lead you astray means that you can't rely on it directly, that you have to do an incremental analysis. And so the question isn't just what's the highest IRR, internal rate of return. The question is the extra amount higher than the MAR? So is the extra cost associated with the more costly option justified? So when you compare things, you discount the revenues at the MAR, not at the internal rate of return. So here's more options. The first example was just 2 options. This is showing what if we had 1, 2, 3, 4, 5, 6 options. 6 different things to choose between. And I've arranged them in terms of increasing upfront cost. So if we did a present worth analysis, we'll find the present value, and we're discounting all of that at the MAR. And so the one that has the highest present worth, it looks like, is alternative E. And so just on the basis of the present worth, we'd say go with alternative E. But again, here's another example where alternative D had the highest internal rate of return. But we're not trying to maximize internal rate of return. We're trying to maximize profits. I mean, it doesn't matter if you got $800 at a high-end interest rate. I'd rather have $900, and I don't care what the interest rate was, because profit is profit. You want to maximize profits, not maximize internal rate of return. So the best choice here, obviously, as a function of the present worth analysis, is alternative E. And so this next slide shows how we would construct the differences. And so this takes a little bit of looking at. So first thing we're going to do is B minus A. So how much more does B cost than A? Extra $600. And we find how much extra revenue is generated. So 276 minus 150, extra 126. So the present worth of that extra amount is $174 when we discount at the MAR. The internal rate of return of that extra investment is 16.4%. So since 16.4% is higher than 10%, that extra $600 was a worthy investment. The same is true with alternative D. Now, I've already eliminated alternative C. I'm not even going to continue to consider it as an option because it had that negative present worth. So now we do D minus B. And so what that is the next most expensive option minus the one before it. We already know that alternative B is justified. And so now the comparison isn't D versus A, it's D versus B, because we've already said yes to alternative B. So D minus B costs an extra $2,500. The rate of return on that, 22.6%. Yes, do it. E minus D, because we've said yes to alternative D, now we have to compare the next incremental amount to that. 15%, higher than 10, do it. When we get to option F, we're comparing F and E, and it's not worth doing because we have to, remember, pay 10% interest to borrow that extra $2,000, but then we only make 8%. Yeah.
Okay, if all right, say you're doing a B minus A and it doesn't pass. Like say it was no.
Yep.
What would be your next?
We go back to A.
A would be A minus.
Okay, so if B fails,
right, it'd be D minus A.
and if B fails, then check D minus A, because we already knew that C failed. And then E minus A. You basically, whatever the last passed alternative is what you're comparing it to. Good question. So here's the outline of our procedure. Sort them by increasing investment, just the column order, that means. Subtract the difference from the alternative before, and I guess I should change that. It's not just the alternative that was before it, it's the alternative before it that passed. Change your notes to say that. And then you find the internal rate of return of the difference, meaning of the incremental amount.
So the higher, I'm guessing the D, well, was that what you said was D?
What? The best option here is option E.
Okay.
It's the last one that was higher than 10%. It generates the most profit.
So the internal rate of return, would it, like
These ones?
yeah, being high, the highest doesn't make any difference?
Nope. Because this is just saying that compared to alternative B, the extra amount is making 22.6%. Well, that's great, but you don't want to maximize internal rate of return, you want to maximize profits. And so you just say, well, what about paying even more? What if I paid even $1,000 more than option D? What would that get me? Well, it would get you an extra $229. Beyond the profits that you had made before.
So it'd be 229 plus 14 on
Mm-hmm.
88.
Yeah.
I guess you could set it up in Excel where it adds it all.
You could add them all up, right? And so it'd be that, plus the present worth of alternative A.
And then on the last one, you would.
And that's what would give you the total present worth of option E.
I got you. Okay.
Yeah. Okay. So I know you're itching to try this out. I don't want you to be delayed in scratching that itch, so I will open up the tablet cart. And once again, I forgot to unlock it an hour before class so you can get these babies booted. What we should do is just start booting them before we leave the night before. Then they'd be all ready to go.
They go to sleep.
Looks like most everyone's getting some pretty good results. So I just want to point out one little issue. So what are the increments that we do? So increment is talking about the extra amount. So we do B minus A, C minus B, D minus C, E minus D, and when you get to it, you'll notice you also need to do E minus C. Because what you'll see from the incremental analysis is that option D fails. Yeah, actually, yeah, since D fails, this one, E minus D, is irrelevant. Because this one fails. So, must compare E to the last one that passed. So we'll find out B minus A is okay. C minus B, okay. Greater than 1. Okay.